Unit 3.4, we do practice. A basketball is left outside in winter when the temperature is -2 degrees Celsius, has a volume of 6.88 liters, and the pressure inside the basketball is 0.795 atmospheres. How many moles of gas are in the basketball, and what is the partial pressure of oxygen in the basketball? So since they've given us a temperature value, a volume, and a pressure, then this sort of gives us a hint, and they've asked us to find the number of moles. This sort of gives us a hint that we're going to be using the ideal gas law. So let's rearrange PV equals nRT so that we're solving for moles. So we have N equals PV over RT. And now let's plug in all of the values that we have and see if that gets us anywhere. So our pressure is 0.795 atmospheres. Our volume is 6.88 liters, and that's going to be over our R value for this, since we're in atmospheres, is going to be 0.08206. And our temperature, when we convert from Celsius to Kelvin, is going to be 271 Kelvin. So when we plug this all in and solve, we get 0.246 total moles that are in our basketball under these conditions. So the next part of the question asks us, what is the partial pressure of oxygen in the basketball? So this is where this portion right here, this table is going to come into play. This is giving us the individual components of the air within the basketball, right? Because the basketball is just filled up with regular atmospheric air, and these are actually the three primary components within atmospheric air. So remember, to find the partial pressure, you're going to multiply the mole fraction by the total pressure of the mixture. So to find our partial pressure of oxygen, we're going to take our total pressure, which is 0.795, and that was given to us in the question, and we're going to multiply it by the mole fraction of oxygen, which is given to us in that table, which is 0.209, and we're going to get a partial pressure of oxygen of 0.166 atmospheres.